Hey, magandang buhay. So ako si Sir Ben at narito ako upang ituro sa inyo paano nga ba mag-solve ng word problems that involves permutation. Ready ka na? Great. So dito sa video na to, 8 ang ipe-present kong problems. Okay? So umpisahan natin yan sa una, syempre. In how many ways can 6 students arrange themselves in a row for a picture taking? So ang gagawin ko niyan dito is since picture taking yan, 6 students, so most likely, magkakaroon tayo ng 6 na upuan. Or in this video, maglalagay ako ng 6 na squares. So yung bawat squares na yan, parang isimbol sila ng upuan. Okay? Doon sa unang upuan, 6 yung pinagpipilian ng photographer na ilalagay doon sa unang position. So 6 ang pwedeng ilagay doon. I mean, 6 yung pinagpipilian. Doon naman sa pangalawang position, since meron na tayong nailagay doon sa first position, sa pangalawang position, 5 na lang ang pinagpipilian. Sa pangatlong position, 4 na lang ang pinagpipilian. Tapos, 3, 2, and then 1. And then, ang gagawin ko lang dito is, imumultiply ko lang sila. So, yung 6 times 5 times 4 times 3 times 2 times 1, that is actually the same with 6 factorial. And 6 factorial, using yung permutation, is the same with the permutation of 6 taken 6. So, in that case, ang magiging sagot natin dito is 720 ways. Napakadali, di ba? Next doon tayo sa pangalawa. In how many ways can 4 different books be arranged in a shelf? So, again, parang kapares lang ng example number 1. Yun nga lang, nabawasan lang tayo ng boxes na ilalagay. So, dito niyan, 4 lang ang ilalagay kong box since 4 na books ang meron tayo. So, syempre, dun sa unang position, 4 na libro pa ang pinagpipilian ko. Doon naman sa pangalawang position, syempre, 3 na lang, tapos 2, and then 1. Tapos, i-multiply lang natin sila, and that is actually the same with 4 factorial, which is equal to the permutation of 4 taken 4, and the answer will be 24 ways. Third problem tayo, or third question, 6 athletes will join a particular competition. In how many ways can they win first, second, and third places if there are no ties? So, dito, since meron tayong 6 athletes, tapos yung ipo-position lang natin sila in 3 position, first, second, and third. So, ang magiging solution natin dito will be the permutation of 6, kasi 6 athletes, taken 3, kasi 3 yung prizes. First, second, and third. Okay? So, permutation of 6 taken 3, that is equivalent to 6 factorial over the quantity of 6 minus 3 factorial. So, syempre, i-simplify lang natin yan. Magiging 6 factorial over 3 factorial. Simplifying that one, yung numerator natin, i-list lang natin hanggang 3 factorial para makancel na itong dalawa. So, may iwan dyan 6 times 5 times 4. And the answer will be 120 ways. So, syempre, meron din another way para isolve ito, yung mas madali. Ito yung method na ginagawa ko talaga. Ang gagawin ko lang yan dito is maglalagay lang ako ng 3 boxes. Okay? Yung first box para sa first place, yung second box para sa second place, and then yung third box para sa third place. So, syempre, dun sa unang box, 6 yung pwedeng manalo. 6 yung pwedeng maging first placer. Doon naman sa pangalawang box, syempre, since may first place na, 5 na lang ang pwedeng maging second placer. Tapos, doon naman sa third box, syempre, magiging 4 na lang. 4 na lang yung pwedeng maging third placer. Syempre, multiply mo lang yan, kamukha na lang nito. So, that will be 120 ways. Okay? Fourth question. So, we have here, how many 4-digit positive integers can be formed using the digits 2, 3, 4, 5, 6 if no digit can be repeated? So, dito sa fourth question na to, ang gagawin ko na lang is boxes. So, ilan yung digits natin? 2, 3, 4, 5, 6. So, 5 lang. So, 5 boxes ang ilalagay natin dyan. 4 boxes. Sir Ben, bakit 4? Kasi, ang question dito is, how many 4-digit positive integers? How many 4-digit positive integers? So, 4 na box lang ang ilalagay natin. So, be careful with that one, no? Okay? So, dito niyan, ang gagawin ko dun sa first box, syempre, 5 ang pinagpipilian natin, so 5 ang ilalagay ko. Doon sa second box naman, 4 na lang ang pinagpipilian natin, tapos 3, tapos 2, and then just simply multiply those numbers and we will get 120. Fifth question tayo. How many different code words can be formed from the letters division? So, kumbaga, itong question to, permutation with repetition, distinct permutation. So, ang gagawin mo lang yan dito is, bilangin mo lang ilan yung letters dun sa word na division. D-I-V-I-S-I-O-N, 8. So, 8 factorial sa numerator. Sa denominator naman, identify mo anong letters na umulit. In this word na division, letter I lang ang umulit. And yung letter I, 3 beses umulit. So, 3 factorial sa baba. Siyempre, simplify na lang natin yan. That yung numerator natin magiging 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. Siyempre, cancel na natin ito. So, matitira na lang dyan. 8 times 7 times 6 times 5 times 4. Multiplying those numbers, yun yung makukuha natin. 6,720. Sixth question. Suppose you are on a 4x6 grid and want to go from the bottom left to the top right. How many different paths can you take? Avoid backtracking and you can only move from right or up. So, illustrate natin yung mismong question na yan. Ganito siya. Okay? So, 4x6 grid. Tapos, you will start dun sa bottom left. Tapos, yung end mo is dun sa top right. No? So, ilang ways daw starting dito para makapunta ka dun sa endpoint natin. So, ilang ways yun. So, pwede ganito yung magiging way ng daanan mo. So, pwede kang mag up, 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 tapos right ng 6 na beses. Pwedeng i-jumble mo yan. Up, up, right, 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 right. Okay, so maraming ways yan. So, kung mapapansin nyo, para din siyang distinct permutation. So, dito, ang gagawin lang natin is bilangin lang natin yung letters dito. So, in that case, this we have 10 letters here. Tapos, yung U umulit or yung up umulit ng 4 na beses. Kaya we have here a 4 factorial. Yung R naman umulit ng 6 na beses. So, we have here 6 factorial. Simplify na lang yan natin ito. Yung numerator natin, that will be 10 times 9 times 8 times 7 times 6 factorial over 4 factorial times 6 factorial. So, cancel na tayo dito. So, may iwan na lang 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. Siyempre, i-cancel na natin yung mga pwedeng i-cancel. Then, yung 9 at saka yung 3, pwedeng i-simplify yan. Then, sa numerator natin, ang natira, 10 times 3 times 7. So, in that case, yung answer sa problem number 6 is actually 210 ways. Number 7. So, yung 7 and 8 is about circular permutation. In how many ways can 6 people be seated at a round table? Napakadali lang nito. So, yung formula is actually n factorial over n, which is equivalent to the quantity of n minus 1 factorial. So, yung n mo dito is the number of people. So, in that case, this will be the quantity of 6 minus 1 factorial. Simplify lang yan. That is 5 factorial. And 5 factorial is actually 120. Napakadali. Tama? Madaling-madali lang ang permutation. Next, last question tayo. So, we have here, how many ways can 3 men and 4 women be seated around a circular table? Yung value ng n mo dito, 7, kasi wala naman restriction dito. Kumbaga, i-arrange lang natin yung 3 lalaki at saka 4 na babae. So, in that case, yung value ng n natin is 7. So, gamitin natin yung formula na n factorial over n. So, 7 factorial over 7. So, yung 7 factorial, that is 7 times 6 times 5 times 4 times 3 times 2 times 1. Cancel mo na yung 7 dyan. So, ang may iwan dito is 6 times 5 times 4 times 3 times 2 times 1. Ito, this is actually equivalent to 6 factorial, which is the same with the quantity of 7 minus 1 factorial. So, ang 6 factorial is actually equivalent to 720. So, napakadali, napakasimple na mga word problems that involves permutation. So, part 1 pa lang ito ng video. Yung part 2, nasa description box na yan. Pwede nyo siyang i-visit para ma-expose pa kayo sa mga iba pang word problems that involves permutations. And with that, maraming salamat sa pakikinig and magandang buhay!